So, hello everyone. Welcome to today's daily Leetcoding challenge. Today we have the day 12th question: merge case sorted list. Here we are given case sorted list, and we will have to merge them into one list, and with all the elements being sorted. The topics covered here are divide and conquer approach and priority queue. But remember, without them also we can get optimized solution. We will see that how. And the most important part of this question is this can be solved using brute force approach, and even that is an optimized solution for it. I'll give you some hints about the optimized solution further, but you will have to go it yourself. I will just give you the approach which is fast here in this case, in this particular case. So coming to the question, we are given k linked list. Linked list, you must be knowing what linked lists are. Each element is connected to the next element. We will link. We are given case as linked list. So the ones which you are seeing here are linked list. They are shown as an array as a list here, but they are actually linked list. Okay. We are given such linked list, and each of them have elements in sorted order. That means one is connected to 4, 4 is connected to 5, one is connected to 3, and then 3 is connected to 4. Similarly, 2 is connected to 6. And each, as you can see, 2 and 6 they are sorted, 1, 3, 4 are sorted, and 1, 4, 5 are sorted. So this is what they are meaning here. So we will have to merge them. What merge means is that since they are individually sorted, we'll have to create finally a linked list in which all these elements will be there, but they all will be in sorted order. So as you can see, there are two ones, so they are here. Then we have 2, which is coming from here, and so on. That means we'll have to take elements from each of the individual list, and then finally we have to create a single linked list instead of k. We'll have to create a single linked list in which all the elements captured from the k linked list into a single linked list in which all are sorted. Yeah, like you can see, this is the linked list structure, and finally our answer should be like this. This is a linked list. Here each node is actually this one, this class, list node class. Here there are two members of this class. One is the value, and then is the link. So yeah, let's come to the solution part. The solution I will like after explaining the solution, I will tell how the time complexity and space complexity are coming. First of all, we are taking values. Very simple list. In this is a Python list actually. Here we are storing only the values of the list. So for example, for this particular node, it has a value component, it has a link component. I will store only the value here, and I will print and show as well how it works. Head and point. I'm point like there are pointers. Head and point. Both are pointing to a list node. That means a member like object of this, which has a value of 0. By default also it's a 0 value. That means if I don't give anything also it will be 0 only. Still I'm giving a value here, less 0. If you don't give also it will work. Yeah, now I am going through each of the individual lists here of all the k. I am going through each of them. I is like, for example, I will be denoting this, like each of them one at a time. Then h is like a pointer to the head of the node. H acts as a head to each of the individual list. I will be traversing through H. Using H, I will be traversing through the list, and I will be appending the values to my the values array. Right? H dot value will be appended to my values array. So I will quickly print and show how it works. So yeah, 145 like yeah, first. Okay. So as you can see, 145 is the elements in the first linked list. So here it is coming, then 134, and then 26, like here. This is the first output. Then we are sorting it, and then we are again printing it. As you can see, it's all sorted now. Remember, this is a simple list. This is not a linked list. There is a confusion in the structure here. This is actually like this, right? Here it is a simple one. This will be making into a linked list now. This we have not created a linked list till now. The answer one. But after sorting it, after collecting all the elements, after sorting them, we will be now inserting them into a linked list. That part is done here. Okay. For sorted value, like for each of the values which I have shown now, for each of these values, I will be iterating over them, and I will call each of them as a sorted value. For each of the sorted value, insert it into a list node. Where is list node? This is the class. I am creating object with value as list node, and then I am making my point. What is point here? Point is like a individual node here, right? Which has value 0. Next statement for that I am inserting this, right? Then I am making point as pointer next. That means always point will be pointing to the latest value which I have appended here. Okay. But remember, head is not changing. Head is always in its position only. Head, the first element will be 0 here, as you can see. The next element onwards, it will be from here. That's when the answer will be returning head dot next, right? Hope you have understood this. Now coming to the complexity analysis of it. Coming to time complexity. Here, okay, first we'll see the space complexity. Here, finally, we are storing the values in an array, right? And from the array, we are creating a linked list. So definitely, it will be of n complexity. Now coming to the time complexity. First of all, I am iterating to each of the elements of it. So here, first of all, let me give what the definition of n is. And in this case, is the total number of elements in the final linked list. That means, yeah, if you count them, whatever comes, that is the n here. Okay, this is the n here. So we are sorting them. This takes n log n complexity. Here we are going through each of the elements. This again takes O of n complexity. Here again we are going through each of them. This takes O of n complexity. So if you calculate, this will be O of n. Then we are sorting the values here, which will be again O of n log n. And again we are going through each of the values, which will be again O of n. So if you combine all the three, we will be getting that the highest will be O of n log n. So this is the solution. It is the optimized solution. If I segment, as you can see, when I ran it last time, it came around 84%. Yeah, 869 it came now. Okay, fine. Now coming to the other solutions possible. Here, this you can also take it as a solution flexi. The concept here is divide and conquer and priority queue. So I will just give you the hint here. See, instead of going all this, what we can do is see, because the array is sorted, we are not utilizing this factor here. Okay, in the solution which we have coded, we are not utilizing this factor here. So what we can do is take the first element of each of the nodes. For example, 1 1 1 here. Sorry. Okay. Okay. Now whichever is the smallest one, try appending it in the answer array. So one came here. Okay. Next, because we took the one from here, next to it will be 4 here, and it will be unchanged. Here it will be 1, here it will be 2. Okay. Now take the next one, which is 1 again. So in this way, what we are doing is we are keeping a head on each of the nodes here. So one head will be on this, one head will be on this, and one pointer which will act as a head on this. Because it's sorted one, we'll be pointing it to the next element once we find that this element is the shortest of all the k. This is one solution which is shown here. Here, see, as you can see here. First will be like if one will be here, 3 and 2. Which of the one is the smallest? We know that one is the smallest. So we will have one here. Next, the pointer will shift it to 2 here. Okay. Out of them, 2, 3, and 2, again 2 is the smallest. So 2 will come here. Then the pointer shifted to 4. And so on, we can go on. So if you consider that solution, then what we are doing is we are sorting them. Like we are going through each of the k list and we are sorting them. So the complexity in this case will be O of k into n. And time complexity will be again C. Ultimately, we are returning a linked list which has k elements. So time space complexity we can't optimize further. Only the time complexity part. Next solution will be instead of like finding which is the smallest of all the can. For example, at a time we are comparing 1 and 2, which is taking actually k amount of time. Okay. So instead of doing that, what we can do is we can use a priority queue. I will maintain a priority queue instead of values here. I will maintain a priority queue here. So I will just insert one here, one from here, and one two from here. But the priority queue will automatically sort them in, you know, and log k complexity. Log k is the sorting one, and we'll go through each of the list. So in that, so if you can see here, yeah, here they are talking about they have not given the demo here. For example, instead of like see in this case we are ultimately doing like see we are comparing 1, 3, and 2 at a time. Okay, so that is taking k time. Okay, O of k, and we are doing it for n elements. That's why O of n into k. But if you use a priority queue, that will be done in log k time. Okay, and that will be doing for n elements. So O of n log k. That is the idea of this question. You can also do it in divide and conquer approach, but again, it will be very complex then. It will become very complex then. But you can, have an idea how it is done. You can just go through it. But as I said, for this question, brute force approach is also optimized approach, which I've coded here. And if you are asked to solve it in another way, I will say like use priority queue. They have used the inbuilt priority queue here and they are solving it. Just go through it. So yeah, friends, that's all from my side. Hope you have liked the video. Please like and subscribe. Thank you.